All right, so today another integrating technique. I'm just going to start with, here's just three integrals. Two of them you already know how to do, and one of them you don't. So my first question to you is, which one of these do you not know how to do yet? And for the ones that you do know how to do, how would you do them? What's the answer to them? Or what's your technique? Okay, hopefully you've had a chance to think about that. You can do this one because it's just a straight integral. It's just an integral of two things that you know how to do, power rule and a trig function. So you can just right away say that that's x squared over 2 minus cosine x plus c, done. There's no special technique there at all. This one, because there's an x squared here and an x here, you can do this by substitution. So we do that one by substitution. So you have u equals x squared, du equals 2x dx, 1/2 du equals x dx. This is sort of the minimum you should write for that. And then so we'd say that that integral equals 1/2 integral of sine u du, and that equals negative 1/2 cosine of u plus c, and that's negative 1/2 cosine of x squared plus c. So that one you can do. Now this one you can't do yet. Why? Because you have this product, but there's no inside function for that product to arise from as a chain rule. So essentially there's a product here, and I can do the integral of a sum. I can do the integral of a product if that product arose from a chain rule. But if I have a product that did not originate from a chain rule, then I need something else. It would be nice if there was just a straight product rule for integrals, and there sort of is. We have something that arises from the product rule for derivatives, and we'll see how that allows us to solve integrals. So here's the product rule for derivatives, okay? So here's for derivatives. All right, what we're going to do is manipulate this a little bit and get something that we can use for integrals. All right, so what we're going to do is we're going to integrate both sides. So we're going to do the integral of both sides. We'll have integral of f g prime. I'm being a little, not sloppy isn't the exact right word, concise by leaving off the dx. I'm just saying whatever this is, we're going to integrate it, okay? So we're being a little notationally frugal, would be one way to say that. So it is equal to the integral of f prime g, because I never stated what the independent variable is. So I didn't really know d what, what would I put? Plus the integral of f g prime. So basically I'm just integrating both sides of this, and I'm not saying with respect to what variable. Now what I'm going to do is say, well look, this one's just the integral of a derivative. And the fundamental theorem of calculus essentially says the integral of a derivative gives the original function back. And again, I've avoided having to deal with having, two different variables to do that with by not stating the independent variables at all. All right, so then this equals the integral of f prime g plus the integral of f g prime. And then what we do is isolate the integral of f g prime. We're just going to isolate this one. And then you can see by just some algebraic manipulation, the integral of f g prime equals fg minus the integral of f prime g. So we got all that just from integrating both sides of the power rule. Now we have a separate notation that we use for integral, for this integration technique. We usually call these u and v. Sorry about that, but that's traditionally what they're called, u and v. And then so what we do is we say it like this. U is not differentiated here, but v is. So what we're going to write is the integral of u dv. All right? So that means that the product of a function and the derivative of another function. And we say that that's equal to uv minus the integral of, this is v. We're going to put it first, and we're going to go v. And this is the derivative of u, so we're going to put it as du. So that, in your textbook somewhere, I forgot what page it's on. Now I'm going to really regret that. It's in here somewhere. Let's see. It should be like 330 something. That was 330 was our. I should have bookmarked this ahead of time. Here's substitution parts. Didn't take too long. All right, page 341, integration by parts formula. That's what I just wrote. They did essentially the same derivation, but they start with u and v. They write their product rule in a little bit less familiar way. So I wrote the product rule in a more familiar way, and then would derive the same thing. Okay, well, so what? How the heck do you use that? That's what we shall see next.